Unit 2. Now we're going to spend a lot of time with this unit because you're going to basically learn how to complete the square. If you've never learned how to use it, you're going to learn it because I don't teach anything else. And completing the square is what you use in calculus when you get to that point. So there's no sense in teaching any other method because you don't use any other method in calculus. So before we learn to complete the square, we need to review over imaginary numbers. Okay, imaginary numbers is basically a housekeeping tool. I tell students it's a housekeeping tool because you can't take the square root of what? Of a negative. So if you can't take the square root of a negative, then why do we even fool with it? Well, we have to write the answer in terms of a variable or in terms of the square root of -1. But the square root of -1 is yucky to deal with, so what we do is we substitute in something for it to make it look nice. And that is I. I is equal to the square root of -1, and I squared is equal to -1. And that's the rule you have to remember when dealing with I. Now, when you get to electronics courses, they switch it to J. But you also got to remember that J is also the unit vector in calculus. So you have to be careful with all these different variables. So just remember that I is equal to the square root of -1, and I squared is equal to -1. And when you have I, you can do the same thing as you can with X. And that's why you do this. This is just for housekeeping. Instead of this, it's better to deal with this. And that's why we do it, pretty much. You can take I plus I and get 2I. You can take I minus I and get 0. You can take I times I and get I squared, which is what? -1. And you can take I divided by I, or I squared divided by I, and get I. Because 2 minus 1 is 1. So the reason you have I is so you can do stuff like that with it. Instead of taking the square root of -1 times the square root of -1, instead of doing this, you just do that. Now, you can do either one, but this is a whole lot more strokes with the pen or the pencil than the I times I is. So it's easier to write. So just think of it as a housekeeping tool. If you don't want to use the housekeeping tool, you can still do this, but it's a pain in the rear. That would be the square root of -1, which is, or the square root of +1, I mean, that's not -1. Square root of -1, square root of -1 is what is in the radical, which is -1. If I took these two things and added them together, it'd be 2 times the square root of -1, or 2I. This is a whole lot easier to write than 2 times the square root of -1. So that's the only reason we use I, is to tell the reader that we're dealing with the square root of -1. Now, another reason we use it is to also say we have x-intercepts. And if you have an I in your answer, that means you don't have x-intercepts. It's as simple as that. But there are a few rules that we have to deal with I, so I'm going to review over those, and then we'll get into completing the square. So, as I said before, I is equal to the square root of -1, and I squared is equal to -1. So I'm going to write that on pretty much every page because if you don't memorize this, you can't deal with I. And something simple, I plus 2 plus I minus 6. This is a simple additive rule, just like you did with X. Treat I the same as X as far as adding, subtracting, multiplying, or dividing. The only thing you have to remember is this right here when you're multiplying. So, I plus I is 2I, and 2 minus 6 is negative 4. So just like if you was to do X. That's why we have I. It's because we don't want to have to write square root of negative 1 50 million times. 2I minus 7 minus 3I minus 2. We'll make that and that's going to give you 2I plus what? 3I, and negative 7 plus what? 2. And what's 2I plus 3I? 5I. And then negative 7 plus 2 is negative 5. So again, the I is treated just like X. The same rules apply that you learned back in algebra and pre-algebra. Now when you multiply or divide, you have to be careful because you might get an I squared in your answer, and if you get an I squared in your answer, you have to change it to negative 1. So, I, what? What's the matter?
Man. Where?
On your phone. Don't move.
Hold. Oh, damn, son.
Good. Dad, come! I thought something was going on. Wow, good job.
I appreciate it.
Dad, come! Thought he was attacking you or something. I plus 3 times I minus 7. All right, use your FOIL method. You get I squared minus 7I plus 3I minus what? 21. Now everything's the same except for this. So what is I squared? Negative 1 plus or minus 4I minus 21. And what's minus 21 and minus 1? So minus 22 minus 4I. That's your answer. Now the only thing that I need to mention to you about I and I is you have to take your highlighter out, and you need to highlight this, that, and that. And just remember that you're always going to get, when you see I squared, you're always going to get a number, and that number is usually going to combine with another what? Number. So you have to be careful when you're dealing with I squared, especially with conjugate. And we're going to get into that next after we talk about the operations. Question on that? And division, you don't see very much. I'm not going to cover too much on division because it's just basically I to the 4th divided by I squared is equal to I squared, which is equal to what? Negative 1. You don't see a lot of division with I. You certainly don't see long division, but you'll do the same principles in long division as you do with X with I. Except you've got to remember that I squared is equal to negative 1 whenever you get your answer. Exponents, you have to be careful with exponents also. Now, I give you a rule. This is a Hubertism rule. I is a fraction. Think of somebody that don't talk proper English like Hubert. I is a fraction of the class, and 1 is a whole. Now, I came up with this my first semester of teaching 102. And the book was teaching divided by 2 and, or divided by 4. I can't remember what the book teaches, because I hadn't taught it so long. And I've come up with this method. I is a fraction, 1 is a whole, odd is negative, and even is positive. Now like I said, this is a Hubertism, so you're not going to see it in the book. And that's when you're dealing with exponents. Exponents with I. So I to the 14th power. What is I to the 14th power? Well, it's I times I times I times I times I 14 times. Now you can sit there and you can actually do each one, I times I is negative 1, I times I is negative 1, and then do all that. Or you can just remember this rule. Divide 14 by 2. What do you get? I to the 7th. 7, what is 7? Is it a whole number or a fraction? Okay, it's a whole number. So that means, even, I'm sorry, is it even or odd?
Odd.
It's odd, so your answer is going to be negative, whatever it is. And then what is 7? Is 7 a fraction or is 7 a whole number? It's a whole number, so whole is what? 1. So your answer is negative 1. Simple as that. You always divide by 2. And when you divide by 2, you get whatever is here.
What's IQ?
Huh?
IQ.
What's IQ?
IQ.
Oh, IQ is equal to 3 divided by 2, which is 1 and what? A half. All right, what is 1? Is it odd or even? Odd, Hubert. That's right, class. And what is 1 and a half? Is that a whole number or a fraction? So the answer is negative I. All right, I to the 12th, or I to the 26th, or whatever you want to get. Let's do another one. Let's do I did 14. Let's do,
38.
huh?
38.
38? I was going to do 24. Let's do 24. Okay, I to the 24. 24 divided by 2 is what? 12. What is 12? Even, so your answer is positive. And is 12 a whole number or a fraction? Whole number, so your answer is positive 1. Let's see, we got negative 1, positive 1, negative I, and what's I? Well, I would be even, but a what? Fraction. So even and a fraction would be like, let's go with 7. I to the 7th. I guess. I to the 7th. No. I to the, I'm thinking of a even fraction would be 2 and a half. Yeah. 5. I to the 5th. Let's go with I to the 5th. I to the 5th. What's 5 divided by 2? 2 and a half. What is 2? Is it even or odd? Even. And what is a fraction? What is 2 and a half? That's a fraction, so your answer is positive I. So that's your 4 possible answers. And it's pretty simple. Now, when you have a negative, let's go ahead and talk about a negative. When you have a negative, you have to go with something else. Go with I to the negative 3. Now, the first thing you need to do with I to the negative 3 is you need to change it to a negative number plus a positive number. So that would be negative 4 to the what? Or I to the negative 4 plus 1. And that would be I to the negative 4 plus I, or times I to the what? Times I to the first. Now this is pretty simple. I to the first is what? I. What are we going to do with this guy? Well, you could break it up into I to the fourth and I to the negative 1.
Or negative 2.
But work with it. Work with it and see what you can come up with. Take a second and work with it. It only takes a couple of seconds to see what you can come up with. Is it? It's stuff logging you out so quick. It's a conspiracy. That's what it is. So what's I to the fourth? Well, 4 divided by 2 is what? 2, so that's a whole number. And it's odd, it's even, so that means positive what? Positive 1 to the negative 1. And then times I. So this one comes out to be I. I can't do anything right today. Maybe it works now. Does it work now? Yeah. All right. So that'd be I to the fourth times what? I to the negative 1. And then this comes out to be 1 times negative, or I to the negative 1. And I. And that's I to the first, right? Now what? Well, what's I to the negative 1 plus 1? 0. I to the 0 is 1. 1 times 1 is. So with a negative exponent, you got to work with it. You got to work with it a little bit. I don't deal a lot with negative exponents. I might throw a simple one up there like that one on the test, but usually I don't even test you on negative exponents. I test you on the positive exponents because you see those more often. But you can work with them. The main thing is breaking them up into terms of I. So, any questions on that?
Where'd you get the 4 times I to the negative third? Where'd you get the other I from?
This one?
Oh, one of the right, yeah.
In order to get a negative 4,
Wait a minute. The I to the right of that.
I need to raise it. I'm sorry. I need to raise it. Hold on. My bad. You're right. Okay. I to the fourth to the negative 1. How about that? Is that better?
Yeah.
And then that would be 1 to the what? Negative 1 times I, my bad. And what's 1 to the negative 1?
Negative, 0.
Are you sure? 1 to the negative 1, 1 over 1 to the negative 1. And if I want to make that a positive, what I do? Flip it. What do you get? 1 times I is equal to I. My bad. You're right. Use the power rule here, not the product rule. Now, the conjugate. Somebody tell me what the conjugate means. If I spelled it right. Yeah, just come on in whenever, that's fine. Conjugate. What does conjugate mean? The opposite operation. All right. The conjugate of x plus 2 is what? X minus 2. The conjugate of a minus b is what? A plus b. This is the conjugate of this. This is the conjugate of this. Same terms, opposite operation. And usually it's with a plus b, a minus b, or a minus b, a plus b. It's usually going to be combining terms or adding and subtracting. Now, we use the conjugate to get rid of radicals in the what? Denominator. You had a good 102 teacher.
He was alright.
He was all right? Okay. Get rid of radicals in the denominator when we are, and you will see this your first semester, your first unit of calculus, because you have to minimize limits, and you have to try to get limits, or these big old terms in the reduced form. And the way to do that is to rationalize the denominator. Now, what I'm going to do is I'm going to review over rationalizing the denominator a little bit, and then we'll get into the conjugate. The square root of 2 over the square root of 7. Now, we're not using the conjugate here, we're just rationalizing. You want to rationalize the denominator. That means you want to get rid of it. So I've got to multiply my term, square root of 2 over square root of 7, times another fraction to get rid of the denominator. So what takes precedence here, the numerator or the denominator? The denominator. You can care less what's in the numerator. So I'm going to multiply. How do you get rid of a radical? Multiply by its whatever's there. So I'm going to multiply by the square root of 7. But I can't multiply it just in the denominator. I have to multiply it where? In the numerator. And the square root of 7 over the square root of 7 is mathematically 1. So whatever your denominator is, when it's a single term, you just multiply by that in the radical. If it was the square root of 2 over square root of 3, then it'd be square root of 3 times square root of 3 over square root of 3. If it's a square root star, then you multiply by the square root of star over the square root of star. And what that does is gives you the square root of 49 on the bottom, which is what? 7. And you can care less what's in the numerator. What's the square root of 2 times the square root of 7? Square root of 14. And you can reduce that into smaller radicals if possible, but at 14 you can't. So you just leave it as square root of 14 over square root of 7. If it's square root of 8 over 7, then you break it up into square root of 4 square root of 2, which is 2 square root of 2 over 7. But 14, you can't break 14 up into anything except 2 times 7, so you just leave it like that. And that's how you rationalize with a single denominator. But what if you have something in the denominator that's not single? Well, then you're going to have to use the conjugate. Let's go with x over the square root of x plus 7. Now here we have a radical in the denominator, and it is a 2-term polynomial in the denominator. So you can't just multiply by the square root of x over the square root of x, because that won't do you any good. Because then that'll give you square root of x times square root of x. Well, that'd be x. But then it'll give you 7 times square root of x, which is a radical in the what? Denominator. So it doesn't help you. So you use the conjugate. What is the conjugate of the square root of x plus 7? The square root of x what? Minus 7. What do you mean put it all in parentheses? You can. I mean, yeah, you can. That's fine. Doesn't hurt anything. Put it like that right there. You can do that. Doesn't matter. You're multiplying. You always multiply by the conjugate. Because what will that give you in the denominator? Shortcut number what? 3. That's right, class. A plus b times a minus b, which is shortcut number 3, which gives you a squared minus what? B squared. So on the bottom, you would have the square root of x, quantity squared, minus the square root of, minus 7, quantity squared. Review back to shortcut number 3. I don't need to review over that again. And that will give you up top x times the square root of x minus 7. Now, by shortcut number 3, you've got the difference of 2 squares. So you square both terms. What is the square root of x, quantity squared? X. So that gives you x in the denominator. And what is 7 squared? So your radical is gone in the denominator, and that's what you want. Now the only problem students have here is they don't know the shortcuts. So that's why I told you to revert back to the shortcuts that I gave you the other day and make sure you remember how to do shortcut number 3, which is a plus b times a minus b is equal to a squared minus b squared. And you don't care what's in the numerator because whatever's there is whatever's there. So x times the square root of x minus 7x. And that's your answer, because all you're wanting to do is get the radical out of the what? Denominator. You can factor out the x right here, but you can't do anything else. You could do x times square root of x minus 7, just like you're right here. You can either write this way over x minus 49, or this way over x minus 49. I'll take either answer. So if you put this on the test, and they say it's wrong, and they give you this over, then you just let me know, and I'll give you credit for it. Okay? All right, let's try nerd. Two over square root of x minus the square root of 5. Let y'all work on that one for a second. start you off. What is the conjugate of square root of x minus 5? Okay, so use your shortcut number 3 on the bottom because that's what it'll always give you. And what will that give you on the bottom? X minus 5. Now, there will be times that they will ask you to rationalize the numerator. And especially in that first unit of calc when they're trying to get you to simplify the limit. They'll give you something like this right here. And they'll say the limit as x approaches 5. Or, yeah. If x approaches 5, what would you get? Somebody tell me what you would get if you plug in 5. 0 where? And what happens there? If you get 0 in the denominator, the function blows up. It's undefined. And that doesn't do anybody any good. And calculus, always remember this in calculus. Nothing is simple in calculus. Alright? If I put, y'all ever seen this, on the internet? And the directions say find x, and the student goes, here it is. Y'all ever seen that? Nothing is that simple. Nothing. There's two things in life. Nothing is free, and nothing is that simple. Alright? If they put this on a test, do you think it's as simple as circling it and saying, find, here it is? No. And when you get a calculus problem, limit as x approaches 5 of x plus 4 over the square root of 5, square root of x minus the square root of 5. Alright, when you get this and you look at it, the first thing you're going to say is cannot be done. Cannot be done are not in calculus. Alright? The whole point of calculus is for you to expand the problem solving process in your mind. Manipulation, patterns, anything. Taking things apart. That is what you're trying to do. So, calculus will not give you a problem that says, find x, here it is. Or plug in 5 and you put, does not exist. It ain't going to happen. So, what do you have to do? You have to multiply by the what? Conjugate, Hubert. That's right, class. Thank you. I heard somebody say it. And what does that give you? It gives you limit as x approaches 5 of x plus 4 times square root of x, square root of x plus 5. I don't care about that. And in the bottom, you get what? X minus what? Alright, now you still get it in there, but most of the time, something is going to cancel out, and this gets done away with. Okay? I think if you plug this in, if you plug this in, this goes away, or something, I think this goes away. I can't remember how it works. But then you get 5 plus 4 is 9, and the limit is 9, or something, whatever the case may be. In other words, you get the radicals out, so the problem works. This one didn't work because I just made it other. Alright? But That's the whole concept. You will use this to get something like this, and then you'll be able to plug in the limit and get another number. And that's what you're going to be doing with the rationalizing the denominator. And you're going to be doing it that first semester when you after you learn that first unit after you learn about limits. Now, with all that being said, let's get to the heart of this unit. %of your test is going to be, or 70% of your test is going to be based on completing the square. Completing the square is a universal way of finding the vertex, the x-intercepts, and you can find the y-intercept by putting in 0 for x. But the x-intercept and the vertex. And it puts it in the form of what you're used to. It gives you f of x is equal to a times x plus h, quantity squared, plus k. It gives you this form. So you'll know what the parabola looks like. When Hubert, my teacher, taught me quadratic formula. That's good if you're used to calculating. Because quadratic formula is only good when you have a quadratic equation full of decimals. Like 2.5x squared plus 3.7x is equal to 2.7 or whatever. And then you use quadratic formula all you want to. Because it would be very difficult to do completing the square with a decimal. You could, but that's the only one. That's the only type problem that completing the square is not the easiest. Completing the square uses basic math. And that's why people like it. And why don't teachers teach it? Well, there's usually two reasons teachers don't teach it. I didn't say not the teachers that do teach it. I'm talking about the teachers that don't teach it. One is they don't know how to do it. And two, they think it's easier to teach you how to memorize the quadratic formula. So they make you sing a little song. And you remember it. And you punch away on that little idiot box. But if I was to ask you what the quadratic formula gives you, you couldn't tell me. It gives a number. Yeah, but what is that number? The x what? X-intercept. So, let's go ahead and take a look at completing the square. The first thing you want to do with completing the square, move C. Now I'm just going to give you the list first. You're going to move C. AX squared plus BX plus C. I love it when I say move C and students go, move it where? Well, it's on the left-hand side of the equal sign. Where do you think you're going to move it? To the right-hand side. Okay, it's not a big deal. I guess you're going to move it up. I don't know. Move it. If it's on the left-hand side, you're going to move it on the right-hand side. All right, 2. Add blanks. There's several ways to teach completing the square. This is the way I teach it because it's called the zero principle method. And I teach it this way predominantly because any other way I've found is more complicated for students to get. 3. Check A and see if it's greater than 1. Okay? You always want to check A and make sure that it's 1. If it's not 1, you're going to have to factor.
Should it be greater than equal?
No. If it's 1, you leave it alone. If it's greater than 1, you have to factor. If A is greater than 1, you will have to factor out A. And we'll get to that. Don't worry. We're going to go through all kinds of completing the square problems. Just like 102s did last semester.
4. And this is the important one. This is the one, this is how you do completing the square. B divided by 2 and square it. And you add it to both sides where the blanks are. By using completing the square, the left-hand side will always be shortcut number 1 or number what? 2. And then you can factor. So, with that being said, we'll go ahead and try a problem. Your problems will be given to you in quadratic equation form. ax squared plus bx plus c. Y'all all remember that because you were told to get a, b, and c out and plug it into negative b plus or minus square root, blah, 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 blah.
I know it if you want to hear it.
No, I don't.
Okay.
Because I think it's silly. Not you. I think it's silly that they teach it.
They come up with a, like a story too.
No, I don't want to hear it either, because that just makes me mad. All right, so 2x, oh no, I don't want to start you off with a is greater than 1. Let's go with x squared f of x, is equal to x squared plus 4x minus 7. Okay, now this problem is not factorable because 7 is a prime number. And what's the only factors of 7? 1 and 7. And 1 and 7 will never give you 4. So you can't factor it. A is equal to 1, B is equal to 4, and C is equal to negative 7. But we don't care about that. So I'm going to find the x-intercepts, right? If I want to find the x-intercepts, what do I plug in for y? 0. So f of x is 0. So I'm going to say x squared plus 4x minus 7 is equal to 0. You're always going to set it equal to 0 because to get the x-intercept, you set y is equal to 0. So the first step is to make sure that it's equal to 0. Or the step before number 1 is make sure it's equal to 0. Number 1, move what? Which one is C? So I'm going to take negative 7. I'm going to take negative 7, and I love it when students say, move it where? I don't know. It's on the left-hand side, so I'm going to move it on the right-hand side. And that'll give me x squared plus 4x plus blank is equal to 7 plus blank. And that is my 2 blanks that I add. Now the third step or fourth step says check A, and we do. A is what? 1, so we don't have to do anything. Right here, A is 1. ax squared plus bx plus c. So A is 1, so we're good. And now we're going to take 4 divided by 2 and square it. And what does that give us? 4. And that 4 goes here and here. That's what the blanks are for. So, that will give us x squared plus 4x plus 4 is equal to 11. That's your quadratic. Huh? We just completed the square. Now we're going to solve and factor, or factor and solve, or whatever you want to do. But I'm going to take it to the next page. All right, I think the last step says use shortcut number 1 or number 2 on the left-hand side. Which shortcut we're going to use? Number 1, because it's a positive. So what is this? Yeah, x plus what? 2, quantity squared, is equal to 11. And at this point, you have your vertex. Now, this form, you can take the opposite of both, here and here, or you can write it in terms of a times x plus h, quantity squared, plus k. So, I'm going to make a note here. Note. You can write it in f of x is equal to a times x plus k, x plus h, quantity squared plus k, or you can just take the opposite of both numbers. Now, if you put it in the form a times x plus h plus k, then you have to take the opposite of the horizontal shift, which I taught you, and take the k and just bring it down, and that'll be your vertex. But with just the opposite, take the opposite of both, you just get what? Negative 2 and what? Negative 11, and that's your vertex. If you do it the other way, you'll get f of x is equal to x plus 2 quantity squared minus what? 11. And that's they call it intercept form. And what's the horizontal shift? Negative 2. And what's your vertical shift? Negative 11. You get the same thing, no matter how you do it. Either take the opposite of both and bring it down here, or put it in this form and take the opposite of the horizontal shift and bring this down like I told you in Unit 1. However you want to do it. I don't care. But you need to make a note of this because sometimes they're going to ask for this form.
What form is that?
Intercept form.
Okay.
And this arrow, I'm going to say, solve for x. So I'm going to rewrite it. X plus 2, quantity squared, is equal to 11. I want you to solve this. Do not use a calculator, because you don't need one.
So when you're writing opposite, you can put it on the left there.
Mm-hmm.
You just go ahead and bring the 11 over. Like when you're writing.
You got to make a decision. Which one do you want to do? Do you want to do the opposite, or do you want to do this?
No, I'm saying, I'm trying to understand that one from, when it says x plus 2 squared minus 11, you just go ahead and instead of making it 11.
You bring that down, and you take the opposite of that. If you do it this way, you take the opposite of both. It depends on which form you want to do it. If you like doing it this way, take the opposite of both, then don't do it this way. But there are some questions on the homework and tests. They want you to put it in this form. They don't want this. They just want that. And you have to bring the 11 over, and it makes it negative. And they want it in this form. So what do? Take the square root of both sides. X plus 2 is equal to, well, the square root of 9 is 3. Square root of 16 is 4. What's between 3 and 4? 3.5. So 9 to 16 is 7. Half of 7 is what? 3.5. So 12.5 is 3.5. We want what? 11. So I'm gonna do it one more time, so that's 3.25. So you can count money. Everybody knows that halfway between $3 and $3.50 is 3.25. So I'm gonna find halfway here. We said that was 3.5. Half of 3.5 is 1.75, which would be 10.75. So I say it's around 3.3. Somebody take the calculator out and take the square root of 11. What do you get? Minutes later,
3.3.
this is a miracle.
Why wouldn't you move the 2 over?
We fixing to do.
Oh.
Give me time. All right. Well, you wouldn't move the 2 over because it's in the block of ice right here. All right. You got to get rid of this square, which gets rid of the parentheses. That's fine. Okay. So now you move the 2 over, and that'd be a minus 2. So x, what's $3.30 minus 2 cents? $2.
All right.
130. So that's one x-intercept. You owe $3.30 and you owe $2. What's the answer there? And there's your 2 x-intercepts. What's your y-intercept? Go back to the original equation. Plug in 0 for x. What's your y-intercept? -7. So you've got everything you need. Sketch this thing. Y-intercept is 0, -7. So now sketch it. Now, I will tell you this. Sometimes they do not want the answer. This is an approximate. You need to write that down. This is approximate. The directions in the book, the directions in the online, the directions on the test may ask for a exact answer. Exact means use the radical. So that would be square root of 11 minus what? 2. That would be your exact answer. That's the exact answer, meaning that you're not approximating the square root of 11. And then sometimes they'll say put it in decimal form. If they put it in decimal form, they're wanting you to give the approximate. Because basically you're approximating. Be able to do both. Because no matter what class you're in, you're going to be asked to do both, whether it's in calculus or college algebra. Now, let's draw this thing. Well, got that much, so I'll just take -2 and 11 over. Oh well, forget it. They didn't even copy it. All right, I'll just rewrite everything. -2, -11 is our vertex. Vertex is your highest or what point on a parabola? Highest or what? Lowest point. It's your bottom of the trough or top of the mountain. It's either one. It's called an extremum. 25-cent word for highest or lowest. Your y-intercept is 0, -7. Was that it? -7? And your x-intercepts are 1.3 and -5.3. So,
Let's just do a negative 5.3 instead of column.
yeah, so I have negative 5.3 and 1.3. So your vertex is negative 2, negative 11. Negative 2, negative 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Your y-intercept is 0, negative 7. 1, 2, 3, 4, 5, 6, 7. X-intercept is 1.3. 1, 2, 1.3, be right in there. And negative 5.3. 1, 2, 3, 4, 5, 6. 5.3, be right in there. And your parabola looks like that.
Zero and zero.
Yep. Now, let's talk about this. What's your domain? Why?
Because of the arrows going to the thing.
Well, it's not a radical or a what? It's not a radical or a rational. In other words, it's not a fraction and it's not a radical. What is it? It's a quadratic. 90% of the time, unless the teacher tells you or the directions tell you, a quadratic domain is going to be what? All real numbers. Because you can put anything in it. You can put a negative, you can put a fraction, you can put anything you want to in it. It'll give you another number. It's not going to give you an undefined function. What's my range? Negative 11 to what? Range is negative 11 to infinity. Decreasing. Decreasing from negative infinity to negative 2. Increasing. Okay, the book will probably not put a bracket here. It'll probably put a parenthesis. I disagree with that, but there's nothing I can do about it. All right? Line of symmetry. What is line of symmetry? Line of symmetry always goes through the vertex. Line of symmetry is x is equal to negative what? 2. LOS equals negative 2. The line of symmetry always goes through the x-intercept, the x-coordinate of the vertex. What is the vertex? The lowest point. In this case, since the parabola is opening upward, the vertex is your lowest point. All right. Your turn. X squared plus 6x minus 10 is equal to 0. Give you about 5 minutes to do what you can. I'll take the roll. Today is a good day to just sleep. All right. So negative 3, negative 19 is way down here. And 1.3 is right in there. Negative 7.3, that's 3, 4, 5, 6, 7, somewhere in here. And what's my y-intercept? Negative what? 10. Now mine looks squatty because I didn't put it on a regular sheet of graph paper. I just sketched it. And that's what you're doing. You're sketching a graph.
How'd you know the y-intercept is negative 10?
Huh?
How'd you know what the y-intercept was?
Plug in 0 for x. What do you get?
Gotcha.
Negative 10. C. C is always your vertical shift or your y-intercept. On a scale from 1 to 10, with 10 being the hardest, this is about a 2 or 3. There is no 1s. They're just 2 or 3s. So that means we need to bump it up a little bit. Right? Yep. Because I want you to excel. I want you to use your brain. I want you to be challenged. I don't want you to go into college calculus and be massacred. Yes? No. What?
When you do the range, it's negative 19 to infinity. But is it a bracket or a parentheses on the negative 19?
I use a bracket, but some books teach that it's not a bracket because when you go increasing to decreasing, range, it would be a bracket.
Okay.
Increasing and decreasing use parentheses because a lot of books say that you don't go there and then you start off from there. Anyway, I disagree with not using brackets on increasing and decreasing, but you just need to keep an open mind on that. Yes, your domain is all real numbers. Your range is negative 19 to infinity. Decreasing is from negative infinity to negative 3. Increasing is from negative 3 to infinity. What's your line of symmetry? X is equal to negative 3. Okay? We good? All right, let's step it up a notch. Because we don't want you to be complacent. Right? X squared plus 3x plus 8 is equal to 0. Students get to this point and they go, okay, I need to take b divided by 2. And they just stop. 3 divided by 2, I think about 3 divided by 2. Yeah, you can. 3 divided by 2 and squared. And what's 3 halves squared?
9/4.
Piece of cake. Now, if you got 9/4 with any problem, then you're okay. If you stopped at 3 divided by 2, I can't do that, or I don't want to do that, then you're a little rusty and you need to get over it. What does that give you on this side? Shortcut number 1, x plus 3 halves, quantity what? Squared, is equal to negative 32/4 plus 9/4. And no, I'm not going to tell you where I got the 32/4 from because you should know. So x plus 3 halves, quantity squared, is equal to negative 32 plus 9 is what? Thank you. Negative 23/4. I'm going to copy that and go to the next page. I'm going to leave that on the board for a few minutes because I know there may be 1 or 2 people in here that didn't get to that point. Just because you divide a odd number by a 2 does not mean that your world ends. Because I'm going to tell you something. There are a lot of these out in the real world. And sometimes you don't turn them into decimals. Especially when it comes to a ruler. Like measuring. Engineers do that, you know. So, We're gonna make a note here, so make sure you got plenty of room to write. I want you to take your highlighter out. I want you to highlight this guy. What's wrong with him? He's a negative. Alright? If you have a negative C on the right side, this right here, and it stays negative, no X what? Why? Because you're going to get an I. Because you can't take the square root of what? Now, if there's a negative 2 right here, then that doesn't apply because you're going to divide by negative 2, and this turns into a what? A positive. So you can't say all the time. But when A is 1, or A is a positive number, and this is negative, chances are you're not going to have any x-intercepts. So that means you've got a floating parabola. It's either out there in one of the quadrants floating, or it's turned upside down, or it's pointing and opening downward, and it's floating into one of the quadrants. In other words, it's not crossing the x-axis. So, our vertex is negative 3/2 and positive 23/4. Now you can change that to a decimal so you can graph it, or you can graph it however you want to, but that's your vertex. I took the opposite of this, and I took the opposite of this. And that's your vertex. If you want it in intercept form, f of x is equal to x plus 3/2 quantity squared, what? Plus 23/4. So, depending on what the directions are asking for, just take the opposite of both for your vertex, or write it in that form. Solve it. X plus 3/2 is equal to the square root of negative 23/4. Now you cannot take the square root of a negative number, and we don't want to write it as the square root of negative 23/4 because that's just a pain. So we're going to use I. I can take the square root of positive 4 because that's negative, or you can put the negative down here, but I don't know why you do that because you can take the square root of positive 4. So I'm going to rewrite it. X plus 3/2 is equal to the square root of negative 23 over 2. No. There's one of these that are negative. Now you can put the negative with the 23, or you can put the negative with the 4. The reason I didn't put the negative with the 4 is I wanted to take the square root of it. Because I can't take the square root of 23, so I might as well put the negative with it. The whole thing is negative, but one of them is negative. So I just brought the negative, instead of putting it out front, I put it with one of them. And I chose the 23.
They were both negative.
Yes, if they were both negative, it'd be positive. So, all right. So this I'm going to rewrite as x plus 3/2 equals square root of 23 times square root of negative 1 over 2. And of course, what is the square root of negative 1? I. So x plus 3/2 is equal to square root of 23. I'm going to put I times square root of 23 over 2. Now, a lot of you are saying, well, why don't you take the square root of 23? There's no use. Why? Because what does completing the square give you? It gives you the what? The x-intercepts, right? Do I need the x-intercepts here? Why?
Because it's
You don't have any. Okay? You don't have any. So what's the use in finding them if you don't have any? You don't need to. So what you do is you just rewrite it in exact form, and you get x is equal to I times the square root of 23 minus 3 over 2. And that is your solution to your no intercept, no x-intercepts. In other words, you're telling the teacher, or you're telling the homework, or you're telling the test that there is no x-intercepts here because you have an I in the problem. Okay, what time's class over? Okay. Well, we'll finish there, and y'all can work on